So n minus 1, you will be given this value of n. So we are not looking at this one anymore. So n minus 1, if your n is 25, then your degrees of freedom will be n minus 1, that will be 24. So if you look at the last sentence on this top paragraph, when using the t-distribution for a single sample, this is a one sample thing. DEF, meaning degrees of freedom, will also be n minus 1. That is the size of the sample, that is the number, that is the value of n minus 1. For instance, if your sample size is 16, your degrees of freedom will be 15. Why do we need these degrees of freedom? Let's go back to this table again. And on the very first column, you see it says degrees of freedom. Normally, let's look at that column. See, they go from 1 to 30 all the way, step by step. 1 through 30. Sometimes your degrees of freedom will fall between 30 and 40, and we don't have those kind of situations. If it does, then we'll make the decision depending on the value. And see, the other things we are given here, 40, 60, 120 and infinity. We normally don't have infinity, we don't deal with that. So how we are going to use this table, that will come once we start doing our calculation. Okay, and the next thing is, if you look at the bottom of page number 122, it talks about the critical values for the t-distribution. Again, the idea is we are still using the normal card. Instead of the z, it will be a t. Okay. So they are describing this table here. It says in the left column, in the left column, various degrees of freedom are listed. That's what we have if you look at the table. The first row, it has various, we are going on this row here. So it talks about the value of alpha, which is the level of significance for one tail test. Next row, it talks about the value of alpha for two tail tests. So we are always going to look at those. The other columns in the whole table, it says in the body of the table, list the critical values we will need to use to reject the null hypothesis. So how do we reject the null hypothesis? Let's look at the next paragraph. In order to reject the null hypothesis, or H sub 0, your obtained t-value will have to exceed the value which is listed here. It has to go beyond that. However, the chart is abbreviated and the critical values are not shown for all degrees of freedom. That's what I was talking about. If the DF for your specific research problem are not shown, then use the critical values associated with the next lowest degrees of freedom. So in other words, if you look at the table, if your degrees of freedom is 39, what is the next lowest value you get from the table? 30. So we have to use the one for 30. We don't have 39 listed here. If you have 50, you will be using the value for 40. So that's what it's telling us. And it says for instance, if your sample size is 54, then your actual DF or degrees of freedom will be n minus 1, which is 53. We don't have that one, so because we don't have that one on this table, then it says in that case we would use 40 to ensure that your obtained t value falls inside the critical region. So we will go one step lower. Let's do this this box on page number 123. Practicing with the T table, we really need to practice this T table. Let's look at the very first value here. Degrees of freedom, it says 11, alpha level is 0.01, and it's a two-tailed test. So degrees of freedom is 11. Let's look at the table and then go on that row toward the value of alpha where it says 0.01. What do we have? 0.01. Degrees of freedom is 11.
2.718.
Nope. Look at the alpha value 0.01. We are looking at this table, this box we are working on.
3.169.
3.169, yes. Okay. So that's the critical value. And our T obtained is 4.32. So do we reject it or do not reject it? Yes. The point is, so that's how we are going to use this table. We are going to look at